everybody, Stephanie here. We are the 16th of November 2023, and today this is episode 3 of how to do a CC65 project with the F256Jr or K. So today it's going to be a continuation on what we started. I've talked about the preliminary setup first. Then I did the video about how the MMU worked. Today we're going to talk about something a bit different. We're going to stay away still from the actual core of the application. In a nutshell, what I wanted to do was to create an application that you could execute from the Junior or K. And actually, when I'm talking about one, I'm automatically talking about the other. I wanted to make an application early on. The way I was going to do this was to start an application where you would have a console, like a console where you type in commands, and the application is to program the flash, the cartridge, the flash cartridge that we have. Do we have one here? Yeah, somewhere. Sorry, it's somewhere. Never mind. And it's essentially, the core of the software would be to specifically say, hey, here's the file, the binary file I want to flash, and say, here's the flash number or the sector number I'd like it to be flashed to. That's basically what it needs to do early on. Very simple, but it can be done from the computer side as opposed to be done from the debug side. Because for example, the flash side from the kernel is only accessible, at least for now anyway, through the debug port. Now, with some changes, I could make it accessible through the software, but it becomes a bit tricky to manage the memory properly. So I don't think there's any need to do this, but when it comes to the cartridge, it's a different story. So, like I said previously, a few seconds ago or a few minutes ago, the idea was to just create an application where within the application you would have like a CLI, a command line instruction, whatever. You give an instruction and say, okay, like program this, but then that kind of interface becomes very complex very quickly. And since we're doing it in C, it's getting bigger very quickly. So the other way to do this would be to simply have an application with arguments, and with those arguments you could actually do the execution right away. So essentially the software would take on all the arguments, look at the different commands, switches in the command, and then just apply and execute whatever you have to do. So if you just want to have if you want to see if there's a sector that is erased or blank or that kind of thing, then you could have a different switch, different results, and so on and so forth. So normally the fundamental aspect of this would be to just say the name of the software is, I'm calling it CWrite. So CWrite would be CWrite dash a switch. And for example, in our example, what we're going to do is like S for sector. You put a number after that saying I want to flash from this sector, and then you would say dash F, for example, dash B for binary file, and then you put the binary file. So when it starts, it reads the argument and then decode the arguments and just execute the command. And Bob's your uncle. That's it. That's all. That's all you have to do. Simple. It's programmed. After that, everybody's happy. We're moving on. So today I thought that I would talk about the arguments, how to get access to your arguments when you're creating software. Now we're going to do it like on a perspective of C, but the idea is the same. When you're doing an assembly, it's the same thing. So I don't want to take too much time because unfortunately I still don't have a lot of time. So I'm going to rush this one. I'm creating this one on the side of the table, but I'm sure it's going to be really useful. So I'm really a neophyte when it comes to that kind of thing. I understand the fundamentals of it, but it took me a while to get to it and to understand exactly how it was going, how it's being done right now. So the way it works, and then I'm going to move on to one of my screen. So I didn't prepare a screen specifically, but I could get into this thing here. So this is the memory that I read from the Foenix IDE after I actually executed my software, where and I'm going to show you what I actually wrote to come to that point. So I wanted to execute. So when you're super basic, for example, when you want to execute an application that resides in Flash, like the same Flash as the kernel, for example. Right now, my program is settled. I'm programming my little C write program at blocks 1E in the Flash. And what happens is when the kernel boots, it kind of registers all the different programs there's a header, and the kernel the kernel will be reading the header at the beginning of every Flash sector. Well, look for one. If there's one, then take on all the information that is in the header and then register it like a registry, if you will, and then just keep it just in case. So when we are in the super basic, this is where we boot. Well, usually what you're going to do a slash, the name of the application, and then you're going to write the arguments that follows. So what happens next, either super basic or the kernel just goes through the argument. And what it does, it's actually putting in the memory, and I'm going to show you where, it shows a pointer to a location of pointers, and then it's going to give you a number, which is the number of arguments. And for anybody who's been doing any software, this is the pointer C, I think, and then the other one is argument V, which is the number. So the number of arguments in the command line. Right? So in our case, right now, as I speak, in the actual version of Super Basic, and again, I'm not even sure if it's Super Basic who does it or the kernel. But either way, we kind of standardized because I think there was different ways to do it. And I think now we're standardized on one way to do it. And how it works is that basically, you see my red cursor, and at 1F, I believe that at 0F8, 0F9, okay, you have the address 0280 here, okay? So this is from address 0 to address 10, so I have the 256 byte page. So this is the absolute address 00F8 and 00F9, which is pointing towards 0280 because it's a little endian or a big endian. And then after that, at FA, you have the number of bytes. In reality, you have to kind of divide this number by 2 to give you the number of pointers. So in other words, this byte indicates the number of bytes that are part of the table. But since it's a pointer of it's an address pointer table, then there's always 2 bytes for every address. All right? So address where the pointer table is and how many bytes in that buffer, if you will, there are. So logically speaking, you have to divide this number by 2 to give you the number of items in the command line. And that includes, and this is very important, that includes the command itself. So don't forget that it includes the command itself. So if we're going to go, so in the page 200, you see the address was pointing at 0280. So at 0280, the first 2 bytes, at 0280, the first 2 byte is 200. 0002 is basically 0200. And as you can see at 0200, this is the first item in the command line, which is the command itself. So if you're running this application, obviously if you want to parse the command line, then you're going to ignore the first one because the first item is the command itself, or is the application itself. So one would eliminate this. So I created a command that says -s4 and -f application.bin. So the second item is going to be located at 0207 because the name, this is the actual ASCII and it's terminated by a 0. So you start at 200, you read this thing, you don't read it because it's the name of the application, you don't need it. But then the second item at 0207, which is here, starts with a dash. So if your command parser, that we'll probably do next time, goes through the list, then you say, I'm looking for 2D. Following the 2D, there will be a letter, and that letter will indicate what is the command. So in that case, it would be S4 sector. In that case, I'll probably keep that letter, and say -S means the sector. Then the numbers that follows is the number itself. So you register this and say, okay, what is the number? Could be an X number, an ASCII number, you decode it the way you want. But specifically in that example, you would have the number 4, which in that case would be sector number 4. And then it's terminated by a 0. All right, a null character, whatever. All right, so when you start decoding the parsing, you take the argument number, you say there was 6, I divided by 3, I remove 1, this is where I'm starting, 0280, 027, and the next item would be a 02B0, 020B, not B0, 020B, and so this is 89AB. The second argument begins here, 02B, and then it says dash, so 2D is dash, so there's another command. 66 is the letter for small f, big F, whatever, you do whatever you want. You do the, small caps or big caps. And then you do the same thing. Okay, this is a -f. What's going to follow is going to be an ASCII string, which indicates the file name. And so you're all set. You have all the parameters necessary to at least program the file, the flash, and then you're doing your thing, and so on and so forth. So that's basically how it works when you're doing an argument. So if you have created an application in assembly, you're going to do the same thing. You're just going to read the first at F8, F9, create an address that points to the list of address, and then the other aspect, FA, will be the number of bytes in the buffer. So in that case, 6. All right? So I think this is pretty straightforward, but if you don't know it, it's kind of not super documented, so I think it's going to be a great idea. So if we go back to our code, let's see. Yeah. So if we go back to our code, in our case, so I'm not going to spend a lot of time with this because I think it's, let me see. Do I want to get involved in, because I talked about how to get started, but before I go, do I want to get here? Do I want to talk about this? Not specifically. I think this one here is more important. So just to wrap up before we go into code, this is the makefile that correspond to the actual project. And I've talked about the name of the lib here that would have to be changed because it's not exactly the same thing. Then in the OBJs here, you include the .o, which is the object file after they compile. In order, in our case, I renamed the thing. If you download the example that I mentioned in the episode 1, the name will be different. And I removed a couple of things. So I essentially kept the kernel library interface, which is the kernel.o. The other is actually the file that talks about the what is the name of the software. I can go through it actually. And then the main, which is the C main that I compile. And then you just mention which one is which. And in the objects file here, and then here you say, hey, the kernel O represent kernel C. The main O represent main C. And then everything else, I think, the makefile, I'm not a pro at makefile. I make at all. I'm like a newbie. I think I understand the whole scripting language thing, but one needs to go in there and really, the syntax is pretty much always the same, but you get the gist. It's like, here's the file I want to compile. Here's the application that are assigned. If I want to get this compiled to do this, either it's an assembly part or it's a C compiling, assembly compiling. So CA65 refers to the compiling assembly. CC65 refers to the sys assembly. And I think what happens is that the CC65 is executed first, created an assembly file, and then the assembly file is being done to create an O file, an object file, and then the linker LD65 put all these little beautiful thing together. All right. So before we go, so just to show you the header, essentially this is what you should have, or something that resemble that at the beginning of the block of where your application would be. In that case, it's 2000. I think I moved it to 8000 because I'm using 2000 to do something else. So you need to have the 2-byte tick signature F256 like this, the number of blocks you're going to use, starting slot, I'm not quite sure, where the execution address will be, where does it start, so this is the execution address. Then there's a new byte. Well, there's the byte that is now, if you set it to 1, it's a new structure, so there's more information. You tell the kernel that you have expanded the header to include more information. So when you're going in DOS, when you're in Super Basic, you do /DOS, then you have access to a list of command that allows you to have access to the list of blocks or application in the flash, and that header provide more information to the user. In our case, we say, hey, we have the extended version, the name of the application is CWrite, and then you explain what it does, application to program, and then you can add the arguments in the second line to say, hey, -s does this, -l does this, -f does this, and so on and so forth. So it's like an help, really embedded in the description of what the application does. It's really, really useful, and so that's what the header is. So if you want to make it compatible to be run within the DOS shell, if we will, or Super Basic, you need to include this little buffer and this little header. And it's going to be the same when you create a program you want to put in Flash, or you want to put in the Flash cartridge. For it to be recognized by the kernel, the microkernel, you need to have this header. Really important. Otherwise, if I move to the main, just to go over what I'm doing a bit of init. I'm setting up the MMU to bring, I believe, the 2 pages of the Flash in block 1 and block 2. Refer to the second episode to have a better understanding how the MMU works. I think block 1 and block 2 of the Flash, because I need to send certain commands, and I'm not going to go through these commands today, next time, but essentially you need to write certain byte a certain address to get the state machine of the Flash to recognize that you're going to do a programming cycle, or to read the Flash version, or so on and so forth. But in this case, we're going to skip. So I'm just preparing the memory configuration. I'm using the feature, I'm replicating what was there before. Essentially, as you can see, I'm reading F9. And again, the way I'm doing things is very basic, very down to earth. I'm not a super programmer by any stretch of the imagination. I'm sure people would do it more beautiful, nice, and proper. But for me, it's always about, okay, is it working? Yes, perfect. So I'm going to read the byte at FA. I put it in Hey. I actually put the value of F9 in I. Then I switch. I put it in J. Then push the bits. I want to recreate my address. I'm going to read F8. And when I'm done here, then I have the content of J, which is the address that I was talking about, which is 0280. And then I'm going to fetch FA, which is the number of bytes, and I put it in argv, which is argc. So I put the value of FA in argc that I've defined as a unsigned character. Now, After that, what I'm doing is that at the beginning I'm declaring, well, forget about the max element because this is a pointer. This is declaring a pointer of a list of pointer, but it's undefined. It's not like if you put brackets. So it's a pointer of a list of pointer, right? So then I say, hey, my list of pointer, the address that points to my list of pointer is indicated at J. So J, please use J, which is 0 to 80, as the value to tell you that it's a pointer to it's an address, right? So I'd say it's a void pointer and saying the argv is a pointer to a list of pointers. So then what I do is that that was my test, my preliminary test, to just say, hey, show me the different arguments value of the pointer table to tell me if I really got those values. And I'm going to run it so you can see it. So essentially, I'm just looking into seeing what I did was right because I fucked around a little bit to figure out, am I reading the pointer? It becomes confusing really quickly, but this is the way I found it to be the easiest way. In assembly, it would have been a lot easier to do this, but in C, just to get the values, it's a bit tricky, but now they're assigned to a pointer table. So now I just can point to the table I want because the table argv is, actually it's a char, it's like a byte pointer. The address is 16 bits, so it's 2 bytes. The table is 2 bytes per location, but it points to a byte, right? And then I'm just saying that if argument C is 2, which means it's just the name of the application itself, then I would say, hey, there's no parameter, but it's very preliminary. And then I just go back to the application. So that's all it does. So if I would go in my other screen, let's say this screen here, and I go into my application here, and I would say make, although I didn't change anything. I think it would say, well, let's say I'm changing something. I'm going to put a space there just to tell it make. Then it's going to do all its stuff. It gives me some warnings. The output bin is the binary file I need. And what I would do normally after that would be to, hold on, I'm going to find the application I need. Okay, so I would take this, my Foenix uploader. You can use Foenix Manager as well to upload your stuff. Hold on, I want to do something. I'm not sure if I'm still connected. No. Okay. Okay, so normally I would be here, connect, choose the output name, output bin. I would say I'm going to put that application in sector 1C. This is where I am. I believe that the size is less than 8K, so I'm still within one block. And I keep the destination at 0. This is where the address of where the file is transferred in memory in RAM first before being flashed into the internal flash. This is not the external cartridge flash I'm talking about. I'm talking about the back. So the application is stored right now in the application, in the flash that is on board. Okay? And it's always good to leave it at 0. And then you just say boot, you just click the flash here and you're going to say, hey, send the file. There's another window that appears but you don't see it that says, are you sure you want to reflash? You say yes. It takes a few seconds. That I already did in first episode. And essentially we're done. So I'm going to reset by hand. Normally it should be resetting. Okay, so this is my capture card. So actually I'm going to just reboot it because something happened. Sorry about that. So I'm switching it off. Okay. This is, I think, a bug because when I write at 0, I actually changed MMU and something about this needs to change. This is a bug I need to fix right now. Not right now, but in the upcoming days. So essentially, like I said, there's 2 ways to go about this when we are so either I can go from super basic. So I would do C write, and I would do -S for and I would say dash F application dot bin. So you do this, the slash thing, right? That tells Super Basic that you're going to run an application. And you see, I have my output here. The contrast is not very good, but normally it should tell me where the first address. Why is it not? Okay, hold on. Wow, this is, you can see it a little bit maybe? Let me see if I can. Ugh. Yeah, so if you could see it, you would see that the first item is 020, the second item is 02007, the third item is 0B, and then it would say number of arguments is 6. Number of bytes that makes the pointer list. All right, so that's kind of weird. So if I scale it back, sorry about that. And I go back. So I leave, I did escape, and I've left. The other way to do it would be to do, no, wrong keyboard. So you go we would be in DOS, so this is DOS, okay? If you do help, just help, no dash help. So you would see that there's a command that's called LSF, I believe. Yeah. So LSF, I have to stretch myself. Okay, so LSF is the list of application in the flash, the internal flash. So you see XDev, Basic, DOS, which is an application in itself. Then you have the Mush client, and you have the C-Write that is using 1C to 1F, which is more or less true. Maybe in the block number it says 3. But essentially that's what it does. And there's a help as well for Super Basic. If I want to go back to Super Basic, I just have to do Basic and it's going to go back. You can do help, I think. And there you go. You have help, which is an application that is already there. And that's it. So you can go in DOS and you could do C-Write and do dash sector 8 dash file hello.bin. And you see the values, same thing, 3 values. Now, if I was going to go here and I would disconnect this little puppy, I don't know if it's going to work. So this is my old Windows. I'm going to remove it. I'm going to have to resign it afterward. It's tricky. And I'm going to connect. And I'm going to go fetch because I use Foenix IDE. I'm choosing, because Foenix IDE uploader has more functions that you can use. You can fetch memory. I'm going to start at 0. I'm going to fetch 4 blocks of 256 bytes. And I'm going to fetch. And I'm going to have a new thing. And I'm going to tell... OBS. No, wrong Windows. Where are you? No, that's not it. That's the one. All right. So it's back again. And you have the value again. Like here's 0280. 0280. 06. Same thing. Different. I would say that. Oops. So 02. Whoops. Wrong table. 0280. You had the first pointer is 02. And then 027, 02B. But the last parameter is different. So if I had a third one, then I would have a new one, and so on and so on. Now, I think it's the best way to go about this way. So if anything changes in the future, then the value of F8, F9 would be different, pointing to a different place. So your thing would work all the time. So it's really important to keep always using the same way of going about this. So that's it, guys. You want to do an application and want to implement some arguments, that's the way to go. I did it in CC65, and you want to do an assembly, it's the same thing. So really a pointer where things are in the list, and that's it. All right, so that's it for me, guys. I hope you enjoyed it. Next time we'll go deeper. I'll start writing the parser and what I do, and I will end up explaining how I go to program the Flash, but then that's going to complete the whole tutorial about how to get started, and within that tutorial I get to tell you how to program the Flash. All right, so I'll see you next time. Take care, and when I have 2 minutes again, I'll make another one. All right, thanks.